Hello students, now we will solve another numerical on power stages and torque of an induction motor. So first we will carefully read and understand the question itself. Question is like a 37.3 kilowatt 4-pole 50 Hz induction motor has friction and windage losses of 3320 watts. The stator losses equal to the rotor losses. If motor is delivering full load power output at a speed of 1440 rpm, then calculate the synchronous speed, the slip, the mechanical power developed by the motor, rotor copper loss, power transferred from stator to rotor, stator power input, and finally the efficiency. Students, first let us analyze the question once again. See, this is given 37.3 kilowatt. The rating itself is given, that it indicates the output power of the machine is 37.3 kilowatt. Then 4 pole, number of pole will be 4. 50 Hz, F frequency will be 50 Hz here. Now, it is given that friction and windage losses are 3320 watts. Okay. The stator losses equal to the rotor losses. Both stator losses and rotor losses are all equal. Next, the motor is running at a speed of 1440 rpm. So, N we have taken 1440 rpm. Now, we will go forward to the solution part. First, synchronous speed is to be calculated, and the very simple formula for finding out the synchronous speed is Ns equals 120 F by P. F is the frequency of the system, P is the number of pole in the induction motor. By putting the values of F and P, 50 and 4 respectively, we will get Ns synchronous speed value as 1500 rpm. Next, bit number 2, slip is to be calculated, and we know the formula for slip is S equals Ns minus N by Ns. So, Ns value we have already calculated in the first bit, that is 1500. N value is given in the question itself as 1440 rpm. By putting these values, we will get 0.04 as slip, or if we will put into 100, the percentage slip becomes 4% here. Next, bit number 3, we have to calculate the mechanical power developed by the motor, that is Pm. Here we have P out given in the question, we have mechanical losses, so the mechanical power or the rotor output will be output power plus mechanical losses. That will come your rotor output or Pm. All these values are given in the question itself, so by putting the values simply, we will get Pm as 40.62 kilowatt. Next, the rotor copper loss is to be calculated. Here we will see another formula for rotor copper loss. That is, we know rotor copper loss by rotor mechanical power equals S by 1 minus Ns. From here, we will get rotor copper loss PCU value as slip into Pm by 1 minus S. Okay. So, by putting all the numeric values accordingly, we will get the answer as 1692.5 watt. Next, again, it can either be calculated in kilowatt or watt. No problem at all. First bit, fifth now, is to calculate power transferred from stator to the rotor, that is P2. P2 power is output of stator and given as input to the rotor. Always remember, if it is written as power transferred from stator to rotor, that is rotor input, P2. P2 formula is mechanical power plus rotor copper loss. Rotor copper loss is calculated in bit number 4. By putting these values, we will get P2 as 42.312 kilowatt. Next, now stator power input, P input we have to calculate. We know stator output P2, which is already calculated in the previous bit. We have stator losses. So, P2 plus stator losses. Stator losses is nothing but the rotor loss given in the question. So, same rotor loss value, rotor copper loss value can be put here. And the answer will come like 44.0045 kilowatt. Finally, the efficiency of the induction motor. Efficiency formula is P out divided by P input into 100. Both the values are now with us. P in we have calculated. P out is given in the question. By putting the values, we will get efficiency as 84.76 in percentage. Next, we will solve another numerical. An 18 kilowatt 4-pole 50 Hz 3-phase induction motor has friction and wind is loss 500 watt. The full load slip is 4%. Compute rotor copper loss, rotor input, the shaft torque and the gross torque. See students, we have P output value given 18 kilowatt, number of pole given 4, frequency value given 50 Hz, mechanical losses given 500 watt and sleep is given as 4% or we can say 0.04. So, first bit, the rotor copper loss. To calculate the rotor copper loss, the formula is Pm into S by 1 minus S. So, Pm is to be first calculated. So, output power plus mechanical losses will give us the mechanical power, that is 18.5 kilowatt. Now, by putting the value of mechanical power here into slip divided by 1 minus slip, we will get rotor copper loss as 770.83 watt. Next, now we have to calculate the rotor input. The rotor input P2 will be Pm rotor output plus rotor copper losses, which is already calculated. So, by putting these two values, we will get P2 as 19270.83 watt. Next bit is to calculate the shaft torque. Shaft torque formula is P out into 60 divided by 2 pi n, where n is the rotor speed and n formula is we know ns whole into 1 minus s. Ns is to be calculated first. Ns 120 F by P. Putting the values of frequency and number of pole, we will get synchronous speed as 1500 rpm. Next, by putting the value of ns, we will get n as 1440 rpm. Finally, by putting the value of 1440 as n in the shaft torque equation, we will get the solution after solving as T shaft is 119.36 Newton meter. And finally, the gross torque becomes Pm into 60 by 2 pi n. So, Pm value we have taken, 60 we have taken, divided by 2 pi into n, which is again 122.68 Newton meter. Thank you everyone.